Uh, so we can see, we can figure out the force that the two exerted, right? Because what was the acceleration of the clay? It went from V final, so it's 0 minus 10 meters per second in a time of 0.010 seconds. Yes? No? Okay. So that means, I don't know what that comes out to be, like negative 1,000. Is it 1.0 meters? Oh, okay. So it was going 1 meter per second. Okay, so we'll just, oh, here you go. So we have negative 100 meters per second squared. Really? Mr. Salas?
This is Salas move. It's like 1 to, he does integral from 1 to 2. It's from 2 to 3, it goes plus 1.
Yeah, there you go. Okay, so we have our acceleration. We know the mass of the clay, so that's easy. The force of the clay is no big deal, right? Because that's just MA. So it's 0.1 times 100, which gives us 10 newtons. Now, what must be true about the force of the block on the clay? Really? What must be true about the force of, like, if this is a force of the clay on the block, what must be true about the force of the block on the clay? Do they have to be the same? You know, equal and opposite and all that jazz? Okay, so technically that would make this 10. But then what is the final velocity?
Wait, actually, the answer said 90.
Ah, why is that? So the force of the block on the clay is 90?
Because I think it's because 100 newtons for 1,000 grams, right? The box is 900 grams, so I think they reasoned that to be 90 newtons. So it's 900.
The force of the clay on the block is 10. Okay, there has to be a way to rationalize this with Newton's third law. What?
The mass of the block.
Is
Interesting.
So they didn't do the.
Well, this isn't the acceleration of the whole thing, right? That's the acceleration of the clay. And then you would say, because how do they rationalize the block exerting a force on the clay that's different?
Oh, like after you get accelerate. No, wait. The acceleration is 1,000.
You have to accelerate that 0.9 kilograms.
That's weird. Because, okay, like, if I slam into a truck, like if I run up and slam into a truck, and this is how fast I accelerate down, that can't be how fast the truck accelerates up, because I exert a force F, and then the truck has equal and opposite force on me. Oh, you know what? Let me do this just to make this quicker, because I know the bell's going to ring in a minute.
Yeah, the final velocity is 1, right?
Yeah, final velocity.
Yeah, trust me, acceleration is 1,000. Because the force is 100.
velocity is kind of
Velocity is 10? I thought the answer said 1.
no.
No, the final velocity is 1.
Was this 47?
That's
what matters.
no, the given.
I know it's given.
You took what?
Awesome. It's blank. Oh, wow, that's weird. It's way down here. Okay, so they're saying... Okay, so they're saying the force on the clay is mass of the clay times acceleration. So yeah, force of the block on the clay has to equal the force of clay on the block. So the accelerations are not equal because the clay is decelerating. Okay.
The acceleration of the block acceleration of the ball, the negative acceleration of the clay is like 1,000, negative 1,000. And the clay
Yeah.
slows
Okay.
down.
Okay. So, like,
Yeah, because
it makes.
because then it's you have
What
to
makes
use-
sense to me is this. I'm not sure how they got this at the end, but they said the force of the clay on the ball has to equal a block, has to equal the force of the block on the clay.
Yeah.
And then that's mass of the clay times acceleration of the clay, mass of the block times acceleration
No,
of
it's
the block.
mass of the block plus the mass of
Or
the
just
clay.
kidding.
It's the,
Oh, for the second part.
Yeah, it's I have to add.
Oh, okay, yeah, sure.
Because that's the final case.
Wait, but I'm not talking about the final case here. I'm saying, okay, if we take a look.
Yeah, but the force, the block on the clay has to carry both of them.
So here you can see like the acceleration of the clay is proportional to the negative acceleration of the block.
Yes.
Okay, so like there's no mass of the clay included here.
They're stuck together.
Yeah, so because we're trying to find like, so then we say that the velocity of each after a certain amount of time is going to be a function of that acceleration, right? And then once we know that acceleration, we can go back and multiply it. We should be multiplying by the total mass then. Oh, they did. Oh, they got 90 for both. Okay, like I knew these two had to be the same. These two have to be the same. That's true. So they got 90 for this and 90 for that. And if we go here, you can see exactly the explanation that they had. And so this is available online also. It's just a function of saying those two forces have to be the same, finding the accelerations, and then going back and calculating the forces. All right, so